What's up, bro chachos? Radical Randy here, and today we're talking about the Pythagorean Theorem. Now I got a question. What does a skateboarder do when he's really good? Go pro! Wah, 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 wah.
First vocabulary term is a right triangle. It's a triangle with one angle measuring 90 degrees. So if you look here, you can see the one angle in each of these triangles measuring 90 degrees is the one with this little red square in the corner. If you see the little red square, that means that that triangle is going to be a right triangle. An acute triangle is a triangle with three acute angles less than 90 degrees. So if you look at each of these triangles, you can see all of the angle measures in each of the triangles measure less than 90 degrees. Therefore, each of them are acute triangles. Obtuse triangles are triangles with one obtuse angle greater than 90 degrees. So an obtuse angle just has to be greater than 90 degrees, and a triangle only has to have one obtuse angle in order to be considered an obtuse triangle. A hypotenuse, that's going to be the side of a right triangle opposite the right angle. So we look for our little red square. The side opposite that red square is called the hypotenuse. It's the longest side of your right triangle. Notice that the other two sides not called the hypotenuse are referred to as legs. A perfect square. Those are just the squares of integers. So on this side, the right side of each of these equations, you can see your perfect squares. I need you to memorize these 1 through 400. There's only 20 of them, but you need to know them in order to eventually simplify radicals. You can memorize them, which I highly recommend, or if you ever forget them, you could just do it out. 16 times 16, 17 times 17, 18 times 18, and you'll get whatever the perfect square is. Now let's talk about the Pythagorean theorem. That says in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So if you were to square each of the legs and add them together, that's going to be equal to the square of the hypotenuse, the side that's opposite the 90-degree angle. In other words, an easy way to memorize this is a squared plus b squared equals c squared. That's how you're going to see the Pythagorean theorem wherever you go. A squared plus b squared equals c squared. If you square the legs and add them together, it's equal to the square of the hypotenuse. Now the converse of the Pythagorean theorem says if the square of the length of one side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. Now what does this mean? Remember, the Pythagorean theorem said if it's a right triangle, then a squared plus b squared equals c squared. This is saying if you're given a triangle and you don't know that it's right, it doesn't have this little red box in the corner, then you do a squared plus b squared equals c squared. If a squared plus b squared equals c squared, then your triangle must be a right triangle. Now the Pythagorean inequality theorems, there's two. The first says if the sum of the squares of the lengths of the two smaller sides of a triangle is less than the square of the length of the longest side, then the triangle is obtuse. So notice this little less than sign. If a squared plus b squared is less than c squared, if you have one really big side, so your biggest side squared is greater than the other two sides squared and added together, then you know it's going to be an obtuse triangle. Okay, one of the angles is going to be greater than 90 degrees, and it's going to be that angle that's opposite your C. The other Pythagorean inequality theorem says if the sum of the squares of the lengths of the two smaller sides of a triangle is greater than the square of the length of the longest side, then the triangle is acute. So if a squared plus b squared is greater than c squared, notice this greater than sign, then you know your triangle is going to be an acute triangle. So remember, if a squared plus b squared is equal to c squared, that's a right triangle. If a squared plus b squared is less than c squared, that's obtuse. And if a squared plus b squared is greater than c squared, that's acute. Now let's talk about how to choose your C value. It doesn't matter which one is A or B, but it does matter which one you choose to be C. So if you're given three side lengths of a triangle, you need to know which one to choose to be C. Just always make your C the greatest number. So whatever's the biggest value of the three sides of a triangle, make that your C value. So here, if you have three side lengths, 9, 12, and 20, the 20 should be your C value. Here, if you have 30, 22, and 25, 30 should be your C value. Here, if you have 3, 4, and 1, 4 should be your C value.
What does surfing and oil have in common? They're both measured by the barrel! Example time.
So example 1 says find the missing side length, and it's a right triangle. We know that because it's got this little red square in the corner. That means that this is a 90-degree angle, meaning it's the right angle, meaning it's a right triangle. So we can use the Pythagorean theorem. Now the Pythagorean theorem says a squared plus b squared is equal to c squared. Now we just got to know which one to put in for a, which one to put in for b, which one to put in for c. So your c is always the longest side. It's always your hypotenuse. It's the side that's opposite the 90-degree angles. That would be c. So c is going to stay c. The a and the b, it doesn't matter which one is which. So your two legs, you just choose one to be a, one to be b. So 3 is going to be our a value, 4 is going to be our b value. Sweet. Now we square each of these because order of operations says we have to square before we add them together. So 3 squared is going to give you 9, 4 squared is 16. What's 9 plus 16? That's 25. Now I have c squared is equal to 25. How do I solve this? Well, I have to take the square root of both sides. Now when I do that, normally what I'm going to do is put plus or minus over here, because anytime you take the square root of a variable being squared, you put plus or minus. But since I'm dealing with side lengths of a triangle, I can ignore the negative version because I can't have a negative side length of a triangle. So I'm just going to make all my answers positive when I do this. So now I take the square root of both sides. The square root and the square cancel out. I get c is equal to, and then over here should be plus or minus 5, but again, we don't need the negative version, so it's just 5. Let's try it again. So here we have our right triangle, and we know that in order to find the missing side length of a right triangle, we use the Pythagorean theorem. Now, which one do we plug in for c? That's the only one that matters. Well, it's the side that's opposite the 90-degree angle. That's called our hypotenuse. So this would be 25. So we're going to plug 25 in for c. And then we can plug in 7 for a or b. It doesn't matter, but since this is already b, why not just leave it b? So we'll plug in b for b. We'll plug in 7 for a, and 25 goes in for our c, our hypotenuse. Now let's simplify this. What's 7 squared? That's 49. What's 25 squared? That's 625. Now to get b by itself, because we're solving for the missing side length, we subtract 49 from both sides. We then get b squared is equal to 576. We then square root both sides. Again, normally when you square root a variable squared, you put plus or minus, but since we're dealing with side lengths of a triangle, we don't have to do that. Here, we cancel out the square root and the square. On this side, the square root of 576 is actually 24, and you're done.
Why did the crew go online when there were no waves breaking? To surf the web! You try.
Okay, let's do the same thing. So again, since it's a right triangle and we're finding a missing side length, we're going to use the Pythagorean theorem. Which one do we plug in for our c? That's the only one that matters. Well, it's the side that's opposite the 90-degree angle. That would be our hypotenuse. That's 17. So 17 goes in for c, and then x, again, could go in for a or b. 8 could go in for a or b. So let's just choose x to go in for a, 8 to go in for b. Perfect. Then we square it. What's 8 squared? That's 64. What's 17 squared? That's 289. Now to solve for x, what we go ahead and do is subtract 64 on both sides, and we get x squared is equal to 225. We then square root both sides, and again, normally it'd be plus or minus, but we don't have negative side lengths of a triangle, so we don't worry about the negative. Square root and the square cancel each other out. We get x is equal to, and then the square root of 225 we know is 15. On this side, again, right triangle, finding a missing side length. We use the Pythagorean theorem. The hypotenuse, the side opposite the 90-degree angle, goes in for our c value. That's the biggest side, so 15 goes in for c. And then again, k and 12, it doesn't matter which one goes in where. We just plug in 12 for our a value, k for our b value. Now, we square each of these. So 12 squared is going to give you 144. 15 squared is going to give you 225. We then solve for k by subtracting 144 on both sides. And we get k squared is equal to 81. Then to get k by itself, we got to get rid of the square, so we square root both sides. The square root and the square cancel each other out, and we're left with the square root of 81, which is 9. K equals 9, and you're done. Now example 2 says find the missing side length. Write your answer in simplest radical form. So here's what's going to happen. Here we again have a right triangle with this little red box, meaning that to find our missing side length, we still use the Pythagorean theorem. The hypotenuse, the side that's opposite the 90-degree angle, that is m. We're going to plug that in for c. Then 8 and 8, doesn't matter which one you plug in for a or b. We then square those. 8 squared we know is 64. 64 plus 64 is 128. To solve for m, now we have to square root both sides to get rid of this squared. And when you do that, the square root and the square cancel each other out. Over here, the square root of 128. Oh, 128 is not a perfect square. So how do I simplify this? How do I write this in simplest radical form? Well, here's what happens. You're going to break up rad 128 into two radicals that multiply together to make rad 128. one of the numbers that you multiply together has to be a perfect square. So we remember perfect squares: 1, 4, 9, 16, 25, 36, right? So is there a perfect square that divides evenly into 128? Yeah, 64, right? 64 plus 64 equaled 128. That means 64 times 2 equals 128. So rad 128 is the same as rad 64 times rad 2. Now what we can do is simplify this. Rad 64 we know is 8. That's the reason we made sure one of the numbers was a perfect square, because it gets to come out of the radical. So the square root of 64 is 8. Rad 2 is going to stay rad 2. You can't take the square root of 2. So instead, we leave our answer m is equal to 8 times rad 2, or 8 rad 2. Let's try part B. Doing the same thing. We have a right triangle and we're finding a missing side length. So what we do is we use the Pythagorean theorem. A squared plus b squared equals c squared. We then plug in our hypotenuse for our c value. So what's our hypotenuse? The side opposite the 90-degree angle. That's this w. So we plug that in here. And then it doesn't matter which one goes in for a or b. We just plug in 20 for a, 5 for b. You could have done 20 for b and 5 for a. You would have got the same answer. So now let's simplify. 20 squared is going to give you 400. 5 squared is 25. We then add together 425, you get 425. Now to solve for w, we have to get rid of this square. So we go ahead and square root both sides. The square root and the square cancel each other out. We get w over here. That's what we were solving for. And then over here, the square root of 425. 425 is not a perfect square. So what we're going to have to do to get it in simplest radical form is we're going to break it into two separate radicals that multiply together to make 425. So one of these numbers has to be a perfect square. So what perfect square goes into 425? Well, 25 does, right? So I can make this rad 25 times rad 17. Rad 25 times rad 17 equals rad 425. Perfect. Now, the reason I did this, the reason I chose a perfect square, is that this rad 25 I can simplify. What's the square root of 25? That's 5. So w is going to be equal to 5 times rad 17, or 5 rad 17.
What letter is a wetsuit the most scared of? The P! Ha ha! You try.
Okay, doing the same thing here. So we're going to start with the Pythagorean theorem. We're going to plug in our hypotenuse for our c value. So h is the side that's opposite our 90-degree angle. That's going to go in for c. 5 and 10, doesn't matter which one goes in for a or b. I plugged in 10 for a, 5 for b. You would have got the same answer if you flipped those. Now what we do is we simplify this. What's 10 squared? That's 100. What's 5 squared? That's 25. We add those together, we get 125. Now to get h by itself, because that's what we're solving for, we're going to square root both sides to get rid of this square. And when you do, over here, the square root and the square cancel each other out. That's why we did that. And on this side, the square root of 125 is not a perfect square. So instead, what we do is we break that into two radicals that multiply together to make rad 125. One of them has to be a perfect square. So that's why we chose 25. 25, we take the square root of, and we get 5. Rad 5, we cannot take the square root of, so that stays rad 5. So h is going to be equal to 5 times rad 5, or 5 rad 5. On this side, again, right triangle, finding a missing side length, that's the Pythagorean theorem. We choose our hypotenuse to go in for c, so the side that's opposite this 90-degree angle, 17, that's going to go in for c. We're going to plug in b for b, I guess, why not? And then 9 for a. That makes sense. We could also flip those, you would have got the same answer. Let's square these. 9 squared is 81, 17 squared is 289. We then solve for b, so we're going to have to subtract 81 from both sides, and we get b squared is equal to 208. We then get b by itself by taking the square root of both sides. These are going to cancel each other out, so we get b, and then the square root of 208. 208 is not a perfect square, so instead what we do is break it into two radicals that multiply together to make rad 208. One of them has to be a perfect square. How about rad 16 and rad 13? We chose 16 because it's a perfect square, and when you take the square root of that, you get 4. So your answer is b is equal to 4 rad 13. Now, something I want you to keep in mind is that sometimes there's more than one way to get to the right answer. Like here, if I have b squared is equal to 208, and I take the square root of both sides. Down here, I broke it into rad 16 times rad 13 because 16 is a perfect square, and I could take the square root of that and get 4 rad 13. But let's say, for instance, you chose to break it into rad 4 times rad 52 because 4 is also a perfect square. This would turn into 2 rad 52. But rad 52 can be broken up even further. There's a perfect square that divides into 52. What is it? It's 4. So I can break up rad 52 even further into rad 4 times rad 13. Now rad 13, there's no perfect square that goes into that, so we're done. Now here, how do I simplify this then? Well, rad 4 we know is going to be 2. And this rad 4 is also going to be 2. So we end up getting 2 times rad 13, which equals 4 rad 13. The exact same thing we got over here. It just took a little bit longer to get there. So you want to think of the biggest perfect square that goes into your number so you don't have to keep breaking it down. Now example 3 says determine if the following triangles are right triangles. If not, specify whether it's acute, obtuse, or right. So here we don't have a little red square to tell us that this is a right triangle. Instead, we're just given 3 sides and we have to figure out, is it acute, obtuse, or right? So what we're going to do is use the Pythagorean theorem and see if a squared plus b squared equals c squared. If it does, we have a right triangle. If it's not equal, then we use one of the Pythagorean inequality theorems to tell us whether it's acute or obtuse. So how do I do this? Well, I have a squared plus b squared equals c squared. Which one goes in where? Well, we only care which one goes in for c, because a and b, you can flip-flop. C has to be the biggest side. So here, that's 29. We plug in 29 for C, and then 20 can go in for A, 21 can go in for B, or vice versa. Now, we simplify it. What's 20 squared? That's 400. What's 21 squared? 441. And then 29 squared is 841. We then add these together, and look, they equal each other. Boom! Because a squared plus b squared equals c squared, we know that this triangle is a right triangle. For part B, now how do we do this over here? Well, we're going to, again, use a squared plus b squared equals c squared. We're going to choose the longest side to be our c, and then the other 2 sides can be a and b. It doesn't matter which one is which. Once we choose our longest side to be c, we then square everything. 2 squared is 4, 5 squared is 25, and 6 squared is 36. We then add these together, we get 29. 29 is not equal to 36, meaning that this is not a right triangle. But we do know that 29 is less than 36, meaning that a squared plus b squared is less than c squared. If you know that a squared plus b squared is less than c squared, you know that this triangle is going to be an obtuse triangle.
What detergent do surfers use to wash their wetsuits? Tide! You try.
Okay, doing the same thing. So for part A, again, a squared plus b squared equals c squared. We need to figure out what kind of triangle is this. We choose our longest side, 28, to go in for c. Doesn't matter which one goes in for a or b for the other 2. We then square each of these, add these 2 together, and you end up getting 900, which is not equal to 784. So this is not a right triangle. Well, is it acute or obtuse? In this case, when we did a squared plus b squared, it was greater than c squared. Because a squared plus b squared is greater than c squared, we know this must be an acute triangle. Over here we have 5, 12, and 13. We choose the longest side to be our right triangle. That would be this 13 right here. So that's going to go in for our C. We then go ahead and plug in 5 and 12 for A and B. Doesn't matter which one's which. We square each of these terms. We then add these 2 together and we end up getting 169 is equal to 169, meaning a squared plus b squared is equal to c squared. Therefore, this is a right triangle. For C, doing the same thing. We choose our longest side to be our C value. So in a squared plus b squared equals c squared, we're going to plug in 10 for C. 5 and 7 go in for A or B. Doesn't matter which one goes in for which on that. We square each of these and add these 2 together. We then see that a squared plus b squared is not equal to c squared. So this is not a right triangle. But we do know that a squared plus b squared is less than c squared, meaning that we have one really big side, meaning that this is going to be an obtuse triangle. Over here, we again choose our longest side to plug in for our C value. 16 is going to go in for C, 8 goes in for A, 15 for B, or vice versa. Once you have that, you square each of these. We add these 2 together, and we end up getting 289, which is not equal to 256. We do know that 289 is greater than 256, meaning that A squared plus B squared is greater than C squared, meaning that this triangle is going to be an acute triangle. Now our word problem says, according to the ladder company's safety regulations, the distance from the base of the ladder to the wall that it leans against should be at least 1/4 of the ladder's total length. You are given a 20-foot ladder to place against a wall at a job site. If you follow the company's safety regulations, what is the maximum distance up the wall the ladder will reach? Write your answer in simplest radical form and round it to the nearest tenth. Whew, that's a lot. Okay, step 1 in the word problem. We're not scared. We can do this. Step 2, we need to define our variables. So what are our variables? What are we trying to find? Well, it says, what is the maximum distance up the wall the ladder will reach? So we're trying to find the distance up the wall the ladder will reach. So if we have a ladder leaning against the wall, it kind of creates a right triangle. You see that? Yeah. Okay, cool. So we're going to find this distance here. This distance, well, it's a leg of a right triangle. So one of the legs of a right triangle, why not call it A? We'll just say A is the distance up the wall the ladder will reach. Well, if this is a right triangle, then we know the other sides. If this is A, then this should be B, and this should be C, our hypotenuse, right? The side that's opposite the 90-degree angle, that's the length of our ladder. Awesome. We now have all of our variables, and we also have the equation we're going to use. Since we have sides of a right triangle, we're going to use the Pythagorean theorem. A squared plus B squared equals C squared. Awesome. The only issue is we don't have anything to plug in for A, B, or C. Well, let's look back at the problem. What do we know? We know that it's a 20-foot ladder. Well, if the ladder is 20 feet long, that means C has to be 20. Perfect. Now that we know that, we just need one more and we can solve for our A. Well, how do we figure out what B is? Well, in the problem, it says the distance from the base of the ladder to the wall that it leans against should be at least 1/4 of the ladder's total length. So B is the distance between the base of the ladder and the wall. And that distance needs to be 1/4 of the ladder's total length. So what is the ladder's total length? That's 20. And what's 1/4 of that? Well, 1/4 of 20 is the same as 20 divided by 4, which is 5 feet. So B is 5 feet. So we know our C and our B, we can figure out A now. So let's plug those in. 20, we're going to plug in for C, 5 goes in for B, and then A is what we're solving for. So we square each of these. We then solve for A by subtracting 25 on both sides and getting A squared is equal to 375. Then to get A by itself, we square root both sides. The square root and the square cancel each other out. And over here, 375, that's not a perfect square. So how do I simplify this? Well, I need to break it into two radicals that multiply together to make rad 375. One of them has to be a perfect square. So what's a perfect square that goes into 375? How about 25? So rad 375, we're going to break into rad 25 times rad 15. We then know that rad 25, the square root of 25 is going to be 5. And then 15, there's no perfect square that goes into that, so that one's done. So your answer, A, is going to be equal to 5 times rad 15, or 5 rad 15. Since we want our answer in simplest radical form, that's what this is, we also want it rounded to the nearest tenth. So in your calculator, you put 5 times the square root of 15, and you end up getting approximately 19.4. So each of these is going to be measured in feet, and that is the maximum distance up the wall the ladder will reach safely.